All right, everybody, what we're going to do is go through some theory on databases. In particular, one database, the MongoDB, Mongo database. And so if you guys are active on YouTube like I am, just got the quick YouTube link. I've found their channel to be very useful over the years, from beginner topics all the way through advanced. So just throwing that out there on the slideshow. And as we jump into it, so where do we start this conversation? And the conversation starts around, in the development world, there are ecosystems, just like at home. I always relate these to, are you an Android ecosystem or are you an Apple ecosystem? And so what you find out when you're in an ecosystem is that it's just a set of related technology that plays well together. And there's a bunch of ecosystems out there, but they're not called ecosystems, they're called technology stacks. And so you get the front ends that play nice with the middle tiers, that play nice with the back ends, all these different technology, these languages, if you will, or these frameworks or softwares, they all play nice together. And so you have these different technology stacks, these different ecosystems. And so you got LAMP, Linux, Apache, MySQL, and PHP. You got Mean, Mongo, Express, Angular, and Node. Very similar to what we're doing, which is Mern. The only difference is the front end is swapped out, right? Mean versus Mern. Right now, Mern is more popular than Mean. That's part of the reason why we're studying it. LEMP, these are the ones I'm a little less familiar with. Linux, MySQL, PHP, Django, Python, Django, Postgres, Ruby on Rails, ASP.NET, which includes C# and called .NET Core, Microsoft Technology Stack, Java is kind of like your Oracle world, and Java EE is the enterprise environment. So these are all just different technology stacks that are out there, and so as a software developer, you have to decide what to study. Well, we rank and decided for you what you're studying based on popularity, based on industry demand. Here in St. Louis, you could say that Mern is the most popular technology stack currently, and that is correct. And then a lot of corporations that work with Microsoft products, they work with ASP.NET. So those are the two technology stacks that we study at Rankin. So in the technology stack, we've already seen Express and Node and React. We've actually, at this point in the class, we've dabbled in all of those. And the only thing we haven't touched is the database, which is Mongo. If you remember the lab, what we did was we stored our data inside of an array, and every time you restarted the application, the data reset. Of course, that's not real world. We need that data to persist. We're going to store that data and work with that data in a database named Mongo. Hasn't been around forever. Mongo database went public in 2017, 2018. So it's boomed in popularity, and for good reason. And so traditionally what you guys had, and you guys have seen this in your first years, you had normalized databases. And that word freaked me out when I first started studying databases. I think I understand what a database is. And then they put in this term normalized databases, and it freaked me out. It scared me because I didn't know what it meant. But a normalized database, what a normalized database is you follow a series of steps to get your database structured and architected in a very specific way. So a normalized database just means that you follow these steps. For example, step 1 of normalization process, normalization is a process, is that all of your tables have a primary key. You guys remember this term? Does it sound remotely familiar from last year? Primary key? A couple people nodding their head yes. Okay, primary keys are ways to uniquely identify the rows in a database table. Okay, remember a database has oftentimes many tables to store data. Think of a table as an Excel spreadsheet, rows and columns. Okay, and then these tables are linked together. They kind of have pointers at one another. And so you can have an orders table, and you can have an items table, and then you have an order item table that says that this is an order ID, a product ID, and a quantity. And so traditional databases are called normalized databases, and they store data in a, they're called, related tables. These tables, they're related and they link to one another. Okay? Data in Mongo is stored much more in a JavaScript-friendly looking manner. Okay, so remember, a technology stack is a group of technology that plays nice together. Well, all our data is stored in the database. It looks like this. It's structured like this. It's not structured like that. Well, which one looks more JavaScript friendly? This or that? The answer is this. This looks like JavaScript, right? It looks like JavaScript object notation. And it is. This is, now in Mongo, they call it BSON, binary object notation, but it's whatever. I mean, what's in the term? It's stored as a JSON object in the database. And so you get the feeling right away that Mongo plays nice in the JavaScript world, in the JavaScript framework. And so, here is the rest of that little, here's another JSON object. And you could see it's got, here you have an array of item objects, right? And here's another order ID. It's got a unique ID. And this one has 2 items on it, right? It's an array of 2 items with a customer ID and an order date. Okay, so traditional, what are called relational database systems versus a more modern way of storing data in Mongo. Now, Mongo is often called NoSQL. Okay, SQL, structured query language. You guys remember select star from orders. Remember that? Raise your hand if you've ever written a select statement before. Everyone's written a select statement before. Well, does NoSQL, it's another one of these terms that you might assume the common sense would mean no structured query language. But it actually, for whatever reason, it stands for not only structured query language. NO stands for not only. Kind of a head scratcher. What NoSQL really means, and you can kind of see here, stands for not only, typically refer to any non-relational database. Some say the term stands for not relational. It says not only SQL. There it is. Not only SQL. Either way, most agree that NoSQL databases are databases that store data in a format other than related tables. We don't have related tables here. We're storing data in BSON or JSON. Either way, whatever you want to call it JSON. I think that's a good, but you could also call it BSON, and that's accurate. Okay? So we don't have rows and columns and tables. That's not to say that you can't have relationship data. Okay? So you can have primary keys and foreign key type relationships. But it doesn't mean that you have to. It says NoSQL data models allow related data to be nested within a single data structure. And I like the nesting. This is nesting, where you're nesting an array of items inside of your orders. Nesting is really the power because you can see it all in one place. Again, we can get into a little bit of the history. NoSQL databases were around the early 2000s. And what's happened, if you guys get into computing history, is like the cost of a hard drive used to be really expensive. And nowadays, it's not, right? So in the old days, maybe you're familiar with this, like a computer used to be the size of this room, or maybe both of these rooms. Computers used to be huge. And the cost of them was astronomical, right? But if you know anything about the cost of computing, is it's gone way down, right? Moore's law is that every so many years, processing speed doubles, and everything gets cheaper and more economical because technology is getting more powerful. TVs are a fraction of what they used to cost. Computers are a fraction of what they used to cost. Everything's cheaper. Nowadays, developers are actually the expensive part, right? You guys heard the salary of the recent graduate. Like, that salary is a lot more expensive to pay than a hard drive, for example. Okay, so in the old days, keep in mind, relational databases, they've been around since the 70s. Okay, in those days, the expensive stuff was the hardware. That's not the expensive stuff anymore. The expensive stuff are the developers. So in the old days, and I'm kind of telling the story as we go, right? You got this graph that shows the cost of a megabyte over time has just dropped through the floor, right? So in the old days, when relational databases were invented, when relational databases were expensive, you had to be really efficient in your data storage. It did not make sense to store a user's name twice. Why would you write the person's name on the hard drive 2 times? That would cost a lot of money, right? If you can store that user's name once and then just reuse it, that's what relational databases did. They had a customer's table, and you store that customer one time. And then the customer would have orders on a customer orders table. Okay, but you're not repetitively storing information. Okay? And so the cost of storage has gone down, and data today is everywhere. You walk into a store, I should mute my phone. You walk into a store, you walk through a scanner, they're counting how many customers are in there. If you got like any sort of customer identifier on you, they want to know who you are. They want to, they're saving information all the time. Weather data is being saved all the time. There's all these sensors out on the highways, in weather applications, in commerce. There's all these sensors. How many of you have smart homes and you got cameras and people walk in front of your house and then now there's recording going off? Okay, or at least you know that goes on. Okay, so data is being saved everywhere. So, number one, the cost of the hard drive has gone down. Number two, we're just saving more and more and more data. If you've heard of the term big data is this idea of like an ocean of data. In fact, there's so much data out there that's been saved, frankly, data scientists don't know how to make use of it. Like, there's just an overwhelming amount of data that people who are paid to study data don't even know where to start. It's an ocean of data. Okay, so with that being the case, data comes in all shapes and sizes. You're getting videos, you're getting pictures, you're getting dates and times. It's JavaScript, it's Java, it's Python, objects, and loosely typed data. And so it's, some data is structured, some is not structured. Some data can shift. It's like a customer object, might have a property, and then the next customer might not have that property. So when it says polymorphic, the shape of your data is changing, right? Depending on the scenario. Okay? So nowadays, like back in the day, everything could be very rigid, very structured, very planned out. And that's how software was in the old days. You used to get manuals like this. This is how you use your software. Old video games had manuals like this. You would flip through the pages, and nowadays it's just like the documentation's not even there. They just push it out to you, and it kind of works, and it kind of glitches, and then they patch it, and then they patch it, and then they patch it. And there's no point in writing a manual because by the time you're reading the paper, it's been patched, and it changes anyways. Do you guys kind of get where I'm going with that? And have you played video games like that before? Right? Do you get a manual like this anymore? Probably not as much as you used to. So that's the strength of Mongo. Mongo can take data in all shapes and sizes and formats and speeds, and that's why it was built that way. It was built to be dynamic and flexible. Relational databases are still, I'm going to make this up, 90% of the market. Relational databases are still very in-demand skill. In fact, I don't say Leo, but Lou, who we interviewed, said that I wish I would have studied more SQL on his interview. Right? Not NoSQL. He wished he would have studied more SQL. Right? So it's still a very in-demand skill, but it's not the most modern skill. This is the most modern, more approach. Okay? And in fact, if you've heard of Agile, yeah.
It doesn't really just go all the way back to SQL.
Doesn't it? Yes, it can. You can still use SQL in here. Is that what your question is?
Yeah, but isn't like old school better than like new school sometimes?
Yes, it's not 100% of the time you should go with this.
Okay.
That is true. So you have to look at your environment. You have to look at the scenario. And I'm not going to say that 100% of the time you go with MongoDB. You might still choose. In fact, on MongoDB's website, they have like a flow chart of like, depending on your scenario, you might still go with a traditional relational database. And right on their website, I've gone through their documentation and read that before. Okay. And so NoSQL plays really well in agile software development. Agile, if you've ever heard software companies, move fast and break stuff. If you've heard that before, move fast and break stuff. Why? Why is it good to move fast and break stuff? Because it's all about time to market. Get something to market, get it live, get people using it, and if you can get people using it, then you can make it better and make it perfect and fix the patches. And so broadly speaking, there's the old school way of building software, which was called waterfall. And in the waterfall methodology, everything was like step 1, step 2, step 3, step 4, step 5, 6, 7, 8, 9. And you stayed on step 1 for 6 months until you went to step 2. And then you went to step 2 for 6 more months, and then you went to step 3. And then you went to step 4. And by the end of it, you had a really clean piece of software that worked really well. It just took forever to build. And so Agile is a more modern software development practice where you're moving fast and breaking stuff. And so, here's an Agile manifesto. This is on Agile Manifesto. We are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value individuals and interactions over processes and tools, working software over comprehensive documentation. Sound familiar? Working software over comprehensive documentation. Customer collaboration over contract negotiation, making money. responding to change over following a plan. And so this is a whole system, what's called a methodology for building software now, is in the agile space. And in agile, you have what are called sprints, and you have stand-ups. And every week, you're meeting with your team, and every day you're meeting with your team, and you're talking about what are you stuck on, what are your blockers, and you're iterating and you're iterating and improving. Let me show you what I've built, customer. Let me show you what I've built. Now make it better. Starting with quick prototypes, that kind of thing. Okay, so relational databases, again, they're still popular, but they do have problems. Hardware in the old day was expensive. Software was cheap. Software engineers, a lot of times, and I've known people like this, they were just hired from within. They might have had a music background or an electrical engineering background, or they became software engineers because they were good workers, and then they started to write code. Software back then didn't need to handle a lot of users. Like in the old days, you get 10, 20, 30, 100 people at a time, and that's the concurrent users in the old days. In the old days, the internet didn't exist. Hard drives weren't efficient, you would say. And business requirements were well known and static. That's another thing. Today, business requirements are always changing. The business people are always changing their mind about what they want built. Databases today need to handle thousands or millions of users at the same time, millions and billions of records. Again, you get these scanners that are scanning every inch of the world and reporting it and saving it somewhere. You need to have multiple database servers, right? Geographically close to minimize the network latency. Hardware is cheap. Developers are expensive. Businesses themselves are always changing. And so the business requirements for what they want built are always changing. And then one note here, and if you guys have ever built a normalized database, you might remember auto increment. You just start it with 1, then you go to 2, then the next record is 3, the next record is 4, and every record in a table is just auto incrementing up. That doesn't exist in Mongo. Instead, what they have are called GUIDs, globally unique identifiers. And so they're unique identifiers that basically are not going to be replicated. So it's a much more secure way of having unique values. Yeah.
Like the nano ID stuff?
Exactly like that. Yeah, exactly like that. And so if there's 500 customers, you know what the next number is. 501. That's a security risk. Is it now someone knows something about your database? And so if they're going to write a query, like a delete star from customer 501, because there's a customer 501. But if you don't know the customer number, you might have a hard time attacking the customer number. It's also can be used in a competitive advantage, right? If your competitor has 500 customers, well, now I know something about your business. And now I know to be, bigger than you, I need 600 customers. Businesses have secrets. They don't want to share their information. When you have foreign keys, a lot of times, it requires synchronization between database servers. When you're synchronizing, that's locking the tables. If you're locking the tables, you can't be inserting new tables. So there's a synchronization process, and then really what that boils down to is your software is going to run slower because you got to lock the table before you can write new information to it. Also, when you have data in all these different tables. The idea of a normalized database is you take a lot of information and you break it across all these tables. When you put them back together, that's called a join. You're joining tables back together. You're joining the data back together. Well, you don't have to join the data back together if it's nested together. If it's already stored together, you don't need to join it back together. Joins are slow, generally speaking. Broadly speaking, joins are slow. And they're not considered a good thing. So just, you can store the data together, and then you don't have to join the data back together. All right, there's a golden rule of Mongo, and I'll write it on the board. If you take one thing from this whole lecture, data, and this might be on the slide, it should be, data that's accessed together should be stored together. Okay? So what does that mean? What does it mean? Data that's accessed together should be stored together. That means if you're looking at a page of information on a website, it's all in one place. That data is accessed together because it's all on one page. Therefore, that data should be stored together in the database. If you have to join that data together, you're breaking that rule. Right? Data that's accessed together should be stored together. That's the Mongo golden rule. And you're going to find out Mongo is great because it's so flexible. You can store data like this, you can store data like that, you can store data however you want in many cases. Mongo is very flexible. It's not rigid, but there is a golden rule, and that's that. By the way, it's called, when you have an entry on a Mongo database, that's called a document. That's called a single document. When you have a JSON object that's stored in Mongo, that's just, they call it a document. That's the language that they use. Let's see what this says. Tables do not allow for nested documents and arrays. So again, tables do not allow nesting of data. So like in that example where a customer had an array of orders, you cannot have in a normalized database, you don't have that nesting. It doesn't exist. Which is why you have to do joins to join the data back together. That last bullet there, a bunch of imagine C#, a bunch of C# classes, because that's what you guys are familiar with, end up being written just to map between the database and the application data. And so, there's data that exists in the database, and then there's data that exists in the application, and you have to create classes to pull the data out of the database and store them in the application. That's often the case in other technology stacks, that they have what are called object relational mappers that'll extract the data out of the database and store them in an object relational database mapper. So objects are in your C#, the database has relational data, and they're mapping the two together. So these things called ORMs are nice, and they help us write code in other technology stacks very efficiently. And so in .NET, the ORM in .NET is called Entity Framework. And we will work with ORMs, and we will work with Entity Framework. But you'll see that, however, they obscure problems with generated SQL, hide a lot of performance problems, and prevent optimizations. And so there's some criticisms of ORMs and the way that they work. And a long time ago, for a long time, relational databases could not work with JSON. Now all the mainstream databases have changed that. Now the mainstream databases, they can work with JSON data, but for a while there, they couldn't. And so that was always a problem. Okay, and I put this slide together. It says, in the end, and this is my opinion, relational databases are not optimized for today's applications. Relational databases cannot handle more than a few thousand concurrent users. Relational databases are not optimized for distributed database servers. Relational databases are not optimized for unstructured and nested data. It says many don't even support it. Okay, so I'm a fan of Mongo. If I'm building a new app today, I'm building it in a NoSQL environment, okay, to support all those things that I just went through. So on the right-hand side, this is the terminology that we're using in Mongo. A schema is essentially a map of the database. Schema. If you want to understand the database, you want to understand the database schema. It's like a map of the database. How is the data stored, in what collections. So think of a collection as an array, and then a document goes inside of the collection. So the schema might have 10 collections. Each collection has a bunch of documents. Each document has a field and a property. So it's just breaking it down. You got the big picture, the schema, and then all of your different collections, these are your entities. What are your entities? The student entity, the teacher entity, the assignment entity. These are your different things. These are your arrays. An individual element is a document. Then you've got, in a document, you've got key and value pairs. Key value pairs, because that's a JSON, right? And how that relates to relational database language is on the left. We're going to focus on the right. We've got schemas, we've got collections, we've got documents, fields, and values. You do not have to define a schema because Mongo is flexible. So your schema can change all the time. You can add collections and fields as needed. Documents can have different shapes. So you could have one student with a property, and then the next student document does not. That makes it so that the application, generally speaking, and I've seen it before, I hesitate to say this, says the application can easily handle changes to the schema when the data doesn't conform to the current plan. And so if you write your JavaScript in a way that uses like, hey, if this property exists, then display this property. Otherwise, don't display the property, right? There's all sorts of syntaxes in JavaScript to say, hey, display it if it's there, don't display it if it's not. Mongo, you can have, it says all fields are optional. And then if you want to have required fields, you basically need the front end to do validation or the middle tier as an express. We are going to do data validation, but data validation will not be done at the database tier. I would actually say that that's not the best. It's good to have some database validation as well. And there is database validation in here, but again, we will use what are referred to as object IDs for our primary keys. I called it a GUID. An object ID is a GUID, right? It's just a random string of letters and numbers. I didn't start my timer, so I'm probably over quite a bit. Now, MongoDB can have primary keys and foreign keys, but it's not a hard requirement. So the note on here says MongoDB provides no way to enforce the validity of a foreign key, and that's a good thing. So remember in normalized databases, you have a primary key like customer 12345. And then if that customer ever has an order, there would be an orders table with a customer ID foreign key in the orders table. And if there's 5 customers and you try and say, hey, customer number 10, and you're trying to use customer number 10 in the orders table, customer 10, number 10 doesn't exist. Okay, so the database would throw an error. The database would throw an exception. And in ways, you could view that as a good thing because it's not allowing a customer number 10 to insert an order that wouldn't work. There would be no customer 10. However, because of having those foreign keys and the data synchronization problems, I could see that being viewed either way. It's a good thing, it's a bad thing. It says, or just nest the related document inside, which is often a better solution. Okay, you guys are going to have final projects, and you're going to be able to make your own database schema. And I would encourage you, because I've taught this class a few times now, if you want to have multiple collections and then break the data apart into multiple collections, or keep the data together in less collections, I'm going to encourage you to keep the data together in less collections and have nested documents in those collections. Okay, that's Mongo's strength. Now, in index, you guys are all familiar with the term index because if you've ever had a textbook before, you refer to the index in the back of the textbook, and it tells you how to look up information quickly, right? So an index on a database is just that. It is a tool on a collection that allows data to be retrieved quickly. Keep in mind, if we have millions of records or billions of records, retrieving that quickly would be the challenge. And so a unique index enforces, kind of like a primary key, unique values for all of your items in your collection. And so it's a way to enforce that. And records could be looked up quickly using that index. Okay, and indexes, again, I kind of covered what those are. We will add indexes to our collections. Okay. And so let's go ahead and have you guys start downloading the tools that you need. Let's go ahead and download MongoDB Community Server. Go ahead and open up the PowerPoint. Go to this slide. Click on the download page. And let's download MongoDB Community Server. To be honest with you, Community Server is the local tool. We're not going to work with the local tool a lot. So, okay, download and install Community Server. You'll have it. Download and install Compass. We will use Compass. Compass is your GUI for MongoDB. So we will use Compass. We will use Mongo Shell.
Which slide is this on?
You just have to navigate until you get to the slide. So I'm asking you to download and install Community Server, Mongo Compass, and let's start there. Just download and install those two things. Let me show you what Mongo Compass looks like. And I haven't connected in a long time. Let's see if my clusters are still... No, I haven't done this in a while, so I'll have to clean this up. So we're going to spend a little bit of time today downloading and getting this all running for all of us. And so I'll stop the lecture here. And we're going to spend some time getting this software up and running.